Welcome to our explainer of Chapter 2. Today, we're going to tear down that intimidating wall of numbers and show you that math is, honestly, just formalized common sense. If you've ever looked at a giant string of numbers and felt your brain kind of shut down, well, you're in the right place. We're about to peel back the layers of arithmetic expressions to reveal the simple, logical building blocks underneath. We'll learn how to read them, compare them, and manipulate them totally sweat-free. Let's get into it.
Here's a quick roadmap for today's explainer. First, meet arithmetic expressions. Second, comparing without calculating. Third, breaking down into terms. Fourth, swapping and grouping. And finally, using the token model.
All right, Section 1. Meet arithmetic expressions. Picture this. We have a student named Malika, and she spends 25 rupees every single day for her school lunch. Now, if we want to figure out her total spending for a normal 5-day week, we don't need to write out a whole paragraph explaining her eating habits. We just translate that real-life situation into numbers. 5 times 25. That compact little phrase captures the entire scenario perfectly. Math is really just a shorthand language we use to describe the real world.
So, the big takeaway here is that an arithmetic expression is simply a mathematical phrase that evaluates to a specific number. And what's actually kind of mind-blowing is that completely different expressions can act as totally different paths to the exact same destination. Like 10 plus 2, that evaluates to 12. But so does 15 minus 3, and 3 times 4, and 24 divided by 2. You can just think of an expression as a neat little set of instructions telling you how to arrive at a final value.
Moving right along to Section 2, comparing without calculating. Okay, look at this setup right here. We need to figure out who has more marbles. Raja started with 1,023 and grabbed 125 more today. Joy started with 1,022 and picked up 128 today. Now, are we going to sit here and do tedious, stacked addition with these big numbers? No way. Let's take a step back and just use common sense. Look at their starting amounts. Raja had exactly one more marble than Joy. But look at what happened today. Joy gained 128, which is 3 more than Raja's 125.
So what does this tell us? Because Joy effectively gained 3 extra marbles today, that easily wipes out Raja's tiny 1 marble head start, and Joy pulls ahead by 2. We absolutely know Joy has more overall. That means we can confidently slap a less than sign between Raja's expression and Joy's expression without doing a single bit of heavy calculation. That is the magic of comparing expressions through pure reasoning.
All right, Section 3. Breaking down into terms.
So, before we can accurately chop an expression up into manageable pieces, we really have to deal with subtraction. Subtraction is tricky because it kind of breaks the flexible math rules we want to use later on. So, the pro move here is to convert all subtractions into additions of negative numbers. See an 18 minus 10? Just flip it to 18 plus negative 10. You're basically just adding a deficit. By making everything addition, we flatten the playing field and make the whole expression super easy to manipulate. Now that everything is hooked together by plus signs, we can easily spot our terms. Terms are literally just the individual chunks of the expression sitting between those addition signs. But hey, there's a really crucial rule to remember. Any chunks tied together by multiplication or division act as a single shrink-wrapped term. So in an expression like 3 plus 6 times 5, that 6 times 5 is one single term locked together. Always evaluate the locked boxes first, then add it all up.
Which brings us to Section 4, swapping and grouping.
I want you to take a second and really think about this. If we have an expression made purely of addition, and we just go ahead and completely jumble up the terms, does it break the math? Do we get a totally weird final value, or does it stay exactly the same?
Well, everyday logic gives us the answer. Look at Manasa getting ready to go outside. Her mom tells her to put on her hat and her shoes. Now, Manasa could throw on her hat first, then her shoes, or she could do shoes first, then hat. Does it matter? Not at all. The final outcome is identical. She's ready to go. And addition works exactly the same way.
So, now that we get the vibe here, let's give these tricks their official textbook names. The ability to swap the order of terms around without changing the final total? That's the commutative property. And the ability to group different terms together first, like putting brackets around 2 numbers so you can add them before the rest, that's the associative property. Swapping and grouping. Basically, your 2 new best friends for making mental math a breeze.
And finally, Section 5, using the token model.
Let's see if these fancy new rules hold up when we toss negative numbers into the mix. We'll test the commutative property using these red negative tokens. On the left, we start with 4 negative tokens and add 2. Boom! A pile of -6. Now on the right, let's swap the order. Start with 2 negative tokens, then add 4. Look at that! We still end up with the exact same pile. Swapping totally works, even when you're in the red.
Now let's see the associative property, that grouping rule, in action. Here we've got an expression with 3 negative terms. If we draw a bubble around the first 2 terms and add them together first, well, -6 plus -7 gives us -13. Then we take that chunk and add it to our final -13 term. Grand total, -26.
And when we put the token models side by side, it's literal visual proof that no matter which tokens you draw a bubble around first, the math is bulletproof. On the left, we group the top rows first. On the right, we group the bottom sections first. But listen, because we are literally just pushing physical piles of red chips together on a table, the total number of chips never changes. Grouping terms differently doesn't magically create or destroy tokens. The sum is always identical.
So, what's the big takeaway from our explainer today? It's that arithmetic rules aren't just arbitrary laws designed by a teacher to confuse you. They are highly logical, incredibly useful building blocks. Expressions translate real life into math. You can compare them using simple reasoning. By converting subtraction, you unlock clear, easy-to-read terms. And once you have those terms, you can swap them and group them however you want to find the answer faster.
Now that you have the tools and the confidence to absolutely crush your chapter exercises, I want to leave you with a bit of a creative challenge. Pick your absolute favorite number. Got it? Okay. Now using addition, subtraction, grouping, and swapping, how many wildly different, massive expressions can you build right now that all value to that exact same number? The rules of math aren't a cage, they're a playground. Go see what you can build.